Section 5.1 should be a review, some stuff that you have seen. We're going to do substitution and elimination to solve a system of equations. Before we get into it though, just to let you know, when we're solving a system, we're finding where the two graphs hit each other. So that gives us a little bit of a feel for what it is we're doing. And you'll see on some of these, I'll show you the graphs. The first method we're going to focus on is substitution. So in substitution, and again, hopefully all this becomes a review, we're going to isolate one of the variables in one of the equations. And then we'll substitute for that variable in the other. So there's usually multiple ways to attack these. What I'm going to do is in the second equation, I'm going to get y by itself. So I'm going to add the x over. So I end up with y equals x plus 3. So now I'm going to take what y equals, x plus 3, and I'm going to replace y in the other equation with that. So the first equation now will look like 3x plus 2 times the quantity, x plus 3, equals 11. Now I have an equation with just x's in it I can solve. So you distribute through. Solve for x. So you'd have 5x. If I subtract over the 6, 5x equals 5, and x equals 1. Now remember with these, you're giving me an x and a y. You're giving me coordinates. So you have to plug 1 in for x to figure out y. You could do it in any of the equations, but by far the easiest place would be right there. So y would equal 4. So I want these answers as an ordered pair. This is the point 1, 4. And just to show you, this is what we did. Here's our first equation. It's a line. My second equation is a line. And the place where they intersect is at 1, 4. So graphically, I can see, oh yeah, that's what I'm doing. Again, on these first ones, we're going to do all of these with substitution. So, and again, I can pick what I want. I decided I'm going to take the first equation and get y by itself. So let's see what I would do. Let's see, I would subtract over 7x, but be careful. That means I have negative y equals negative 7x minus 10. And then I'd have to divide everything by a negative 1 to get y equals 7x minus 10. I'm sorry, plus 10. So I have what y equals. So now I'm going to take that and plug it in for y in the second equation. So this will give me 3 times 7x plus 10. Make sure you distribute that through. Minus x equals 10. So I'd have 21x, but then minus an x. So that's going to be 20x plus 30. Equals 10. And if you solve through, you'll get 20x equals negative 20. So x is negative 1. Still need the y. I would just plug in negative 1 for x here. That'll tell me what y equals, which is negative 3. I'm sorry, positive 3. So your point is going to be negative 1 for x, 3 for the y, and you're done. Now remember, with these problems also, you can always check these, and you can check them pretty quickly. If you just plug in the x and y into both original equations, they should work. So you should get negative 10, you should get 10. So checking them doesn't take very long, and it ensures that you did this correctly. And again, these really are two lines. There's the first one, there's the second one, and I can see that they are hitting at -1, 3. For number 3, I think the easiest thing would be to take the first equation and get x by itself. Basically, that's going to mean dividing everything by that -2. So if I divide every piece by -2, I would have x equals, let's see, that's going to be -3y minus 9. Again, I just divided everything by a -2. So now I can take -3y minus 9 and replace x with that. I'd have 5y minus 3 times the quantity, -3y minus 9. Be careful here. I'm distributing a -3, so that's going to be positive 9y plus 27. Group some like terms, so I've got 14y. If I subtract over the 27, that's going to give me -56. If you divide by 14, you get that y is -4. I still need the x. Easiest place to plug it in would be right there. And if you do that, you'll get that x is 3. So my point here is, 3 for the x, -4 for the y. Again, I would like them as an ordered pair. And again, you can check these. You can plug in 3 for x, -4 for y into your originals. If it works in both, you're good. For number 4, again, I'm doing substitution, so I'm going to get the x by itself in the second equation. That seems the easiest thing. So it would be, I just add over the y, so it would be y plus 12. So now I can take that and plug it in for x. So this will give me 5 times y plus 12 minus 5y equals 3. So I've got 5y plus 60 minus 5y equals 3. You notice there's an issue here. 5y minus 5y is gone. I have 60 equals 3. This is a special case. That's not true. That means that this is what's called an inconsistent system. All these other ones have been consistent. This one is inconsistent. There are no solutions. And to further drive the point home, remember, these are lines. We're trying to see where the lines hit. Well, what does it mean if the lines don't hit? Here are my lines. It means, oh, they're parallel lines. That's the only way I could have 2 lines that never cross. So graphically, these are parallel lines. So it's an inconsistent system, meaning it doesn't have any answer because they are parallel lines, it turns out. For the last 3, we're going to do elimination method. So elimination method is where you may have to multiply one or both equations by some constants so that if you add the equations together, one of the variables will go away. And again, you've probably done this. It may have been a little while. And it's up to you which one you want to eliminate. But on the first one, it's going to be easier to eliminate the y's because they already have opposite signs. If I just multiply the first equation by 3, so notice I'm multiplying everything by 3, that's going to give me 9x minus 3y equals negative 12. I had to distribute that 3 to all of it. The second equation I don't have to change. X plus 3y equals 12. If I now add these two equations together, the y's are going to eliminate themselves. So I'm left with, when I add them, 10x equals 0. Now that's perfectly fine to get 0 over there. If I divide by 10, x is 0. Now remember, I still need to figure out the y. I could go to any equation in either one of these or over here, plug in 0 for x and solve for y. It's really up to you. I would say this would be the easiest place in the very first equation. I'd have 3 times 0, 0. So I'm really left with negative y equals negative 4. So y is 4. So my point is 0, comma 4. For number 6, again, I think the y's are easier to get rid of just because they already have opposite signs. But this is a case where I need to multiply both of them. So I've got to think, what is the least common multiple of 4 and 5? The least common multiple of 4 and 5 is 20. So I'd have to multiply the first equation by 5 to get it to 20. I have to multiply the second equation by 4 to get it to that negative 20. So my first equation would be 25x plus 20y equals negative 10. For the second one, I'm multiplying 4, so that's going to be 16x minus 20y equals, that's going to be 92. If I add the equations together, the y's will become eliminated. And while the numbers don't look great, they do turn out convenient. I end up with 41x equals 82, which makes x equal 2, which is not too bad. And now again, I've got to plug that in somewhere to figure out y. So maybe I go to this top one. So if I plug that in, that would give me 10 plus 4y equals negative 2. If you solve for y, y is negative 3. So my answer is 2 comma negative 3. And again, you can always check these by plugging them back in for x and y. The last one gets nasty. So we're going to take our time on this one, though. First thing is that I don't really like having all these fractions happening. So this goes back to some previous stuff we've done before. I am going to multiply the first equation by its least common denominator, which between 3 and 4, that would be 12. So I'm going to multiply everything by 12. Again, this is not the elimination part of this. This is just to get rid of these fractions. So if I do that to the first one, 3 and 12 goes to a 4. So 4 is getting multiplied. And that's going to give me 8x minus 4. For the second fraction, 4 and 12, that'll go to a 3. I'm going to distribute that 3. So that's going to give me plus 3y plus 6. And then 12 times 4 is 48. Okay, now I'll further clean that up by just combining some stuff, moving constants over. So I'd have 8x plus 3y. I'd have 2 over there, so if I subtract it over, that's going to leave me with 46. All right, so I didn't change the first equation, I just made it cleaner. So there's my first equation. For my second one, I'm going to multiply by 6, because that's my least common denominator of 2 and 3. So I'm going to multiply by a 6 on all this. Actually, let's zoom this in so we can see a little better of what I'm doing. So the first one, 2 goes into 6 3 times, so 3 is getting multiplied. Give me 3x plus 9. For the second one, 3 goes into 6 twice. Now be careful here. This is a -2. That's going to get multiplied to the x minus y. So that's going to give me minus 2x